I mean, people voted for this problem, so for some reason. Uh, yeah. I mean, so here's what's happening. You have you take the powers of G mod n, where G is something that's not 0 or 1 mod n. Um, you This is of ZRT, is it obvious? Like, I actually don't see why it's true even when n is a prime. So I want to solve the prime case first and then figure out how to do the general case, because the general case is probably just follows from CRT, but the prime case gives me more to work with, I think. Well, let's do n equals prime first. Like, let's do n prime first. And what this is saying is I pick G and look at powers of G. And you split 0 to n minus 1 into G equally sized intervals. And let AI be the number powers. Yeah, G is not a primitive root. But it's really weird because it's like your G is your generator, but it's also the number of things you break into intervals, which like seems very strange to me. Like, why would you? Like, my first question is why would you do that, and the second is like what? Powers of G in each interval, and then the goal is to show some AI is nice somehow. So let's like work through one example so that I can like not have kind of get a sense of what's going on. I'm gonna take let p equals what's a prime? Let p equals 13, and we'll let like g equals like what's a 5. So g to the I, the powers of g mod 13 are 5, 12, 8, 1. And I'm splitting 13 into 5 equally sized intervals. So first let's sort it. 1, 5, 8, 12. Okay, so my intervals are like, so A0 goes up to like 2.6, is that right? Yeah, 2.6. So it picks up so yeah, so this problem. Okay, if they're all if it's just one, I'm going to be upset. 5.2, 7.8, A3, A4, 13. Yeah. Also, I think just the intervals are just weird. Like, I don't understand why this is like a thing you would look at. But sure enough, when I add these up, I get 0. So, okay. Here's something stupid. Stupid idea. Question. AI equals AG minus I. Like, is it just symmetric? It would be symmetric if, it's symmetric if -1 is in the power. Like, if your G hits -1, then you get a mirror image. So, then yeah, then it just works. Is that right? Like, if it's symmetric, I'm okay. Right? Actually, I need to worry a bit about that middle interval. But it's okay because n is odd. I'm still assuming that n is a prime for convenience. Actually, n is always odd anyways because g squared minus g is obviously. So middle interval is okay, yeah, because there will always be an even number of guys in there. Is this like the order is even? Yes, this is what happens when the order is even. So what that means is that this G was not a good example for me to look at because it's just symmetric around negation. And I want to look instead at a different example. So what's a G for which the order is odd? Oh no. Oh, see, 13 is bad because the order is like G equals 3 is the best I can do, right? Then, okay. 1, 3, 9. And so now A0 equals 1, A1 equals 1, and A3 equals 1. G can be even or odd. I don't see. So this is still quote unquote symmetric, but it's sort of in a vacuous way. I'm not surprised this example is uninteresting. I think I want a different example. Don't we still about where it? No, I don't think so, because the middle one has value g minus 1 over 2, right? Like it's a sub g minus 1 over 2. Because n is, yeah, you need the middle guy to be even, but the midpoint of the interval, 6.5, is like a half integer, and in general, n is always odd. Like, n is odd. Even in the generic case. Are 1 and 3 both in their interval 13/3? Oh, wait, sorry, the interval's changed. I was using the old interval. Okay, so A0 is 2. Sorry, you're actually right. And A2 is 1. Thanks, Hardar. Yeah, sorry, for some reason I changed. I thought it was the same intervals. So, I guess G equals 3 is such a bad example because... Like, you know, there's too few intervals, actually. On the other hand... I want to use G equals 9, actually, even though it's a square. I think 9 is better. Because if G equals 9, you get the same power set, but the intervals split differently. So that's an interesting thing you can do. Is like if you want to have the same intervals, but or have the same G set but different intervals, you can do G equals 9. Okay, so if G equals 9, something miraculous is going to happen because there's so many intervals and so few values that I'm astonished that it actually fits. So what are the intervals? Jesus, 1.3, 2.6. Okay, so we agree that A0 always has something in it. 13 over 9 is about 1.3. So A2 is 1. And A... 1.4. So 8.4... I need the rest of the small. 1.44444, 8.64, 6, 6. So I want A7. And sure enough... 2 plus 7 is divisible by... Nope, something's wrong. 1.3, 1.4... Wait, what? No. Intervals have length. Oh, wait. Oh, G is not even less than n. Oh, that's horrible. That's actually horrible. Sorry, this should be A6. So this case actually shocks me, I think. Like, the fact that somehow if I have a cubic number, then like... Yeah, something dumb is happening. Like, this is a scam. We're definitely being scammed. Thanks it's Nimi1 for the follow 2 minutes ago. We're definitely being scammed. But what the heck? It's definitely a scam. Evan knows how to Twitch like a bro. I might have spent a little too much time on these overlays. Oh shoot. Okay. Why? What the? Yeah, the ski is on the white screen. This problem is a scam. Oh my god. I don't know. Didn't mean to do that. Oh shoot. Didn't mean to do that either. Okay. If I try p equals 13 and g equals 13,000,003, I might get the insight. Okay, I'll take. Do you watch anime? Kinda. DBS. Yeah, find me on my anime list and you can find my listing. I haven't had time to watch in a while though. Okay, we'll take Andrew's suggestion. So let me start a new slide and I'll just look at that one example. So, we're gonna take p equals 13. I think this problem is just beating garbage. We'll do 13,003 so that it's not too large. So again, the intervals. Well, the main thing that changes is the intervals. So g to the I is still 139. And what are the intervals? So it's not even A0 anymore, right? You need to get all the way up to 1. Where it's like 13,003. Someone in actually good math problems said there are no okay. Where I equals. Oh, I see where this is going though. Yeah. So the point is that somehow, rather than thinking about it in terms of AI, what I really should be doing is I have this residue, and I'm looking at like there's a contribution which is like the index and it's the floor. So the fact that the AI is being multiplied by I is extremely important. And in fact, alright, okay, I see where this is going. So sum AI is equal to the sum across powers of G. I'll just call them like elements of B. How about that? B of floor. It's like some floor. That floor is N. I'm just gonna go N now. B. Mod N. Is that literally it? I am now convinced this is the correct way to write the expression. It's B. Oh, sorry. You're right. B times G over N. So G times B. Okay. All right, so now let's extract. Okay, so G has an order mod n. We'll call it E. Let E be the order of G modulo n because G is relatively prime or something. And now we just sort of like k equals 0 to E minus 1 of floor of G floor frac G times k plus 1 or something. Oh wow, I got so excited about the floors I put 2 of them. It's also not G to the K. Did I mess up? It's G to the K. Oh, right. Sorry. G to the K mod n. So, mod n. Oh, that's unfortunate. Okay, what do I do with this? Double floor. Ah, someone please simplify this for me. Yeah. Okay, well, I'm going to start by like writing like something. So this is like G to the K plus 1. Or it's like G to K plus 1 minus like some integer thing, right? Minus some term that depends greatly. I want to call it block A for now. I want to see how the rest of it simplifies. With the proviso that this is actually all less than 1 or something. Oh no, wait, this is like less than G. G, yes, sorry, you're right. G times block A. Okay, what is going on? This is horrible. Wait, so we're taking mod G minus 1, so it's modulo G minus 1 over n is invertible. So, this is like sum of k equals 0 to n of like, it's not G times block A? It is block A. Okay, I'm not crazy. Okay, so that's just like sum of 1 minus blah sub when I take mod G minus 1. Okay, alright, now I have to actually write out what block A is. Where blah So the point is that it's the remainder when G plus 1 mod K is divided by n, right? And it's like reasonably okay. Uh. You should use AMS math though. Like you should just always use AMS math. Okay, so amazing. So we're reduced to showing that what is this? Yeah, you should just always load AMS math and AMS sim. It will make your life easier. So okay, so we're essentially adding up g plus g squared. Wait, I don't see how you finish. Oh, wait, we're taking one. So, well, what's the statement I want? I want this thing to be... Your expansion isn't correct. Okay, that would sort of explain a lot of things. Go back to equation 2. Oh, yeah, sorry, you're correct. This is not a correct expansion. Man, okay, it's so annoying because, okay. You know what, I'm gonna take whoever suggested. We're just gonna use percent notation. Like, this is ridiculous. Percent. Comment out. Comment out. Comment out. Okay, and this is okay, so now if I write this whole thing out, minus g times g to the k percent n percent n. This is so bad. Okay. Oh, okay. Okay, a miracle happens, which is that when I take mod g minus 1, one of the g's goes away. Also, this one is also... Okay, if I compose the percent operators, you can just... Okay. Oh my god, this is amazing. I have an extra paren, don't I? Okay, so it telescopes! Alright, so it just telescopes to 0. We're fine. Oh shoot, yeah, k plus 1 is... Yeah, k plus 1. Well, use percent, and people will know what you mean, because there's... I don't entirely get the expansion. Basically what I did is I bashed out everything with fractional parts. Like I literally... this is gk percent n is the definition of b, and then... you know... The floor of x over n is like x minus x percent n all divided by n, right? Like, this whole blob here is this, and you repeat it here, and then take mod in again. So to write out what happened was that floor of a mod n. Oh, the first sum rewriting. Oh, because what happens is, well, for every element of b, so every literal b, it contributes to some index ai. The index of that I is the floor of g times b divided by n. sort of by definition. Yeah, AI is the number of elements in B in the ith bucket. So yeah, exactly. Can we sometime revisit the China problem? Yes, we can. But I think I'm switching to Hanabi for today because I promised certain people that we'd play Hanabi at 10:30 Eastern, and that's exactly now.